and exams. So you put a double star here for you to practice and go back and review this one. Okay. So with the identities, given the exact value of one trig function evaluated at theta, we can find all 6 trig functions evaluated at theta. That's because once you know one, you can knock down the next domino and keep going from there. So given any trig function, we automatically know its reciprocal trig function. Given that tangent of theta is negative 2/3, we know that cotangent of theta is negative 3/2. So that's the first domino we can knock down. Okay. The next one, let's use the Pythagorean identity. So for the Pythagorean identity, we'll go ahead and use number 2 and 3. Okay. So number 2 says tangent of theta plus 1 is equal to tangent squared of theta plus 1 is equal to secant squared theta. So we're using number 2 because we're given tangent of theta, so we can plug it into the identity to find secant of theta. Okay, so let's plug in. Tangent of theta is negative 2/3. So we have negative 2/3 squared plus 1 is equal to secant of theta squared. Okay, or actually, we put the square there so we know that it's secant of theta quantity squared. We should say it that way. Okay, so let's go ahead and solve for secant of theta. Negative 2/3 squared, that's 4/9. Let's get a common denominator. So 1 can be rewritten as 9/9. Secant of theta quantity squared is 13/9. Okay, so that means secant of theta by itself is going to be square root of 13/3, but we put plus or minus. Yesterday, we called this the seatbelt step to circle the quadrant. And I was looking over our exam 1 results, and some of the errors did come from missing a plus or minus sign. Always check your quadrant, and that's going to determine whether the trig function is positive or negative. Okay. So in quadrant 4, x is positive, y is negative. Secant is the reciprocal of cosine. So in quadrant 4, cosine is positive, sine is negative. So that means secant will also be positive, and then cosecant would be negative. Cosine and secant are positive in quadrant 4. So we'll circle that. Okay. Let's start with Stephanie. So Stephanie, we've knocked down 3 dominoes, or we are given 1 and we knocked down 2 dominoes. Now that we know secant, what's the next trig function that we can get easily? Let's hear from Stephanie. Stephanie, check your mic.
Can you hear me?
Yes, so yes, we can. Now that we know secant is positive root 13/3. What's the next trig function we can get?
Cosine?
That's right. So what will cosine be?
That would be 3 square root of 13/13.
Yes, so cosine is a reciprocal of secant. So when we flip it, we get 3/13, but we do need to rationalize the denominator, or else your answer will be marked wrong if you do not rationalize the denominator. So make sure to do that. So cosine of theta is 3 root 13 over 13. That's right. And Stephanie, is your cosine value positive or negative?
Positive.
Yes. Cosine and secant are positive in quadrant 4. That's right. Okay, so next, let's go ahead and use the third Pythagorean identity to find cosecant. So the third Pythagorean identity tells us that cotangent squared plus 1 is equal to cosecant. Okay, so cotangent of theta is -3/2. Plug that into our identity, and now we're going to solve for cosecant. This is 9 over 4 plus 1. We can rewrite this as 9 over 9. But actually, we need a common denominator. So let's rewrite it as 4 over 4. There we go. That's equal to cosecant squared of theta. So cosecant squared of theta is 13 over 4. That means that cosecant is square root of 13 over 2 plus or minus. Okay, so again, let's pay attention to the quadrant. Theta is in quadrant 4. In quad 4, cosine and secant are positive. Sine and cosecant are negative. Because the y coordinate is negative in quad 4, so sine and cosecant are negative in quad 4. Okay, Genesis. Now that we have cosecant, what's the next one we can find?
Sine.
Okay, yes, great. So once we get one, a trig function, we can get its reciprocal next. I want to shrink this. Okay, so now that we have cosecant of theta is negative square root 13 over 2. So that means sine of theta, that's the reciprocal of cosecant, that's going to be negative 2 over root 13. But we need to rationalize the denominator. So that means sine of theta is going to be negative 2 root 13 over 13. Okay. Negative 2 root 13 over 13. So take a look at what we did here. We were given tangent of theta. So reciprocal of tangent of theta is cotangent of theta. That's the first domino we knocked out. Then we use the Pythagorean identities, number 2 and 3. Given tangent and cotangent, we are able to find secant and cosecant. Since we're in quadrant 4, secant and cosine were positive. Cosecant and sine were negative. Okay, so pay attention to the plus and minus signs. Once we have secant and cosecant, take the reciprocals to get cosine and sine. So from tangent, we're able to get cotan. From tan and cotan, we're able to get cosecant and secant. And then from cosecant and secant, we're able to get sine and cosine. Okay, so check that you have your plus and minus signs correctly. In quadrant 4, the phrase goes, all students take calculus. So cosine and secant are positive. The rest should all be negative. And we can see from the plus and minus signs, x coordinate is positive, so cosine and secant are positive. Y coordinate is negative, so sine and cosecant are negative. And then tangent is y over x, negative over positive should be negative. Are there any questions with this problem? that we noted as important to review? When you want to add or subtract fractions that don't have the same denominator, you need to get a common denominator in order to combine those fractions. And when you're taking the square root of both sides, remember there's two roots, plus or minus. Look at the quadrant to determine if your answer will be positive or negative. And then always remember to rationalize the denominator. Okay, I don't see any questions, so let's move forward. Okay. So we're going to move to number 4. We're adding to our list of identities. The fourth group is called odd even identities. Odd even identities are ones that you may have learned as a college algebra student. When functions are odd, f of negative x is equal to negative f of x. So the negative sign goes from inside to outside. When functions are even, f of negative x is equal to f of x. Since our function is symmetric about the y-axis, so for even functions, the negative sign gets dropped. Okay. So for odd functions, negative sign goes from inside to outside, inside to outside, inside to outside, inside to outside. For even functions, negative sign gets dropped. So cosine and secant are even. The rest of the trig functions are odd. So cosine and secant, they're the two functions where when you switch the c and s, you get its reciprocal, secant. Cosine and secant, that reciprocal pairing, those functions are even. The rest of the trig functions are odd. So sine, cosecant, tangent, cotangent are odd functions. Cosine and secant are even functions. Thus, sine, cosecant, tangent, cotangent, those graphs are symmetric about the origin. Cosine and secant graphs are symmetric about the y-axis. Okay, so to prove or to determine whether a function is odd, even, or neither, we have to negate the input. So this is a strategy. If you're asked to determine if a function is odd or even, you're going to negate the input. Negate the input to see what comes out. Okay, so if the negative sign goes from inside to outside, the function is odd. If the negative sign gets dropped, the function is even. If neither of those cases are true, then your function is neither even nor odd. Let's take a look. So we're going to negate the input and simplify. So we get cosine of negative 2x over negative x. Cosine is an even function, so cosine of negative 2x is equal to cosine of 2x. Cosine is symmetric about the y-axis, so cosine of negative 2x is equivalent to cosine of 2x. Okay, so that means what we get when we compare it to f of x, it's the opposite of f of x. Because f of x is cosine of 2x over x. This is the opposite of f of x. So when we negated the input, we got opposite of the output. The negative sign went from inside to outside. Therefore, f of x is an odd function. Mathematicians love to abbreviate, so the 3 dots in a triangle represent therefore. Okay, let's do it again. So negate the input. Negate means we want to find g of negative beta. So replace the input with negative beta. Okay. Sine is an odd function, meaning the negative goes from inside to outside. Cosine is an even function, meaning the negative sign inside gets dropped. For odd functions, negative goes from inside to outside. For even functions, the negative sign gets dropped. Okay, so let me write this. It's negative sine of beta plus cosine of beta. Okay, so students, what do you think? Do you think the function is odd, even, or neither?
Would be odd.
So put your answers in the chat. What do we think? We negated the input. We use what comes out to determine if the function is odd, even, or neither. So share in the public chat for participation. Okay. Jimmy is correct. It's neither. And Jacob, Stephanie are correct as well. Because take a careful look here. What comes out, so that's not equal to, oops. For it to be odd, g of negative beta would have to equal negative g of beta. For it to be even, g of negative beta would have to equal g of beta. So this would be, if g of negative beta, if the negative sign went from inside to outside, it would be odd. If the negative sign got dropped, it would be even. However, I'll put off to the side here, negative g of beta, that would have been negative sine of beta minus cosine of beta, because that negative sign gets distributed. And then g of beta is just sine of beta plus cosine of beta. Okay. So our output here, underlined in red, is neither. It's not negative g of beta, and it's not g of beta. Because negative g of beta, that negative sign would have distributed to both terms. So our expression does not equal negative g of beta, does not equal g of beta. Therefore, we can say that g of beta is neither even nor odd. We'll say neither odd nor even. So remember that when we have a negative sign on the outside, it distributes to every term. Okay. To recap here, if you ask to test if a function is odd, even, or neither, you're going to negate the input. Then simplify. If what comes out is opposite, so if what comes out, the negative sign goes from inside to outside, that would be an odd function. If the negative side goes from inside to positive outside, that would be an even function. If your output is neither even nor odd, then it's neither. And then when it goes from inside to outside, it would have distributed to every term. Okay. Our last example to wrap up 3.1, we'll also star this one, good to review. So the tools that we have in our toolbox so far, we have reciprocal identities, tan kilotan identities, Pythagorean identities, and even odd identities. Let's use what we have in our toolbox to simplify these expressions. So the applications you're going to see in chapter 3 are simplify, do proofs, and then later in chapter 4, solve trig equations using our trigonometric identities. Okay, so the first step, let's go ahead and take care of the negative signs. These are sine and cotangent are both odd functions, so the negative is going to go from inside to outside. If we can't simplify any further here, then our strategy is to change everything to sines and cosines. Negative times negative is positive, so now we have sine of x times. Jacob, what is the identity for cotangent? We want to change everything in terms of sines and cosines to simplify further.
It would be cosine of x over sine of x.
That's right. Tangent is sine over cosine. Cotangent is cosine over sine. Correct. Okay, anything divided by itself is always 1. So our expression simplifies to just cosine of x. Okay, let's do the next one.
So we drop the negative when you use the identity to put it cosine x over sine x.
Well, the reason why the negatives are dropped because negative times negative is positive. So for example, -4 times negative.
Oh no. Oh yeah, I was looking at the when you switch cotangent into cosine and sine. Never mind. I get what you're saying. Okay,
Yeah.
thank you.
Great. Okay. So next, let's look at our part B. Cosine is an even function. So for the even functions, the negative inside gets dropped. Okay. Okay, so we'll indicate that. And then we said when we are combining, let's see, this one's gonna take a little more space. So let's move it down here. Or that's fine, we're good. When we're combining fractions that don't have the same denominator, we have to get an LCD. And to help us with this one, let's say that our denominators were, let's see. Okay. 1 plus a, actually put this in a different color. So let's say this was 1 over 1 plus a plus 1 over 1 minus a. I call this the apple method, substituting your trig function with a. Sometimes it makes it easier to do the algebra steps when your trig function is just a variable a. Okay, so Genesis, thinking back to algebra, here we'd have to get a common denominator. What would that be?
Would it be parentheses 1 plus a times 1 minus a?
That's right.
Yeah.
Very good.
Mhm.
Okay. So as an algebra student, we would know that the common denominator here is 1 plus a times 1 minus a. Okay. But we need to rewrite each term with the common denominator. So for the first fraction, if we're multiplying in 1 minus a, we need to multiply that in top and bottom. The second fraction, if we're multiplying into the denominator, 1 plus a, we need to multiply that into the top and bottom. let me repeat that. So here, the first term, we are missing a factor of 1 minus a in the denominator. So we multiplied 1 minus a into the numerator and denominator. The second term, we are missing a factor of 1 plus a in the denominator. So we multiplied 1 plus a into the numerator and into the denominator. Whatever we multiply into the bottom, we also need to multiply into the top so that our fraction is equivalent. We want to get equivalent fractions, but now with the same denominator. Okay, let's do the same thing for our problem. So the first fraction is missing 1 minus cosine of x. So you need to multiply that into top and bottom. The second term is missing the 1 plus cosine of x. So we'll multiply that in to top and bottom. Okay. Stop me if you have questions. Okay. So all we did here is to get a common denominator, because a common denominator allows us to combine the fractions. So the first fraction, to write it equivalent with the LCD, we had to multiply 1 minus cosine of x top and bottom. Second fraction, to write it equivalent with the LCD, we had to multiply in 1 plus cosine of x top and bottom. Now with the same denominator, we can add the numerators. So let's keep the denominator. Keep the denominator. And now we can combine the numerator. Numerator, we have 1 minus cosine of x plus 1 plus cosine of x. Okay, so there's a lot of simplification we can do here. Let's do it step by step. The first step here, negative cosine plus cosine, that's 0. And then on top here, 1 plus 1 is 2. Okay, back to the side panel to help us with the algebra steps. So here we would have, this would be 2 over actually, let's do it this way. This was 1 minus a plus 1 plus a over this. On the bottom, we have 1 plus a, parentheses, and then 1 minus a in parentheses. So we have 2 over. Let's hear from Justin. So Justin, the denominator here, I'm going to circle it. When we multiply it out, what do we get?
It'd be 1 minus a.
So when we multiply it out, we need to FOIL.
Well, yeah, well, once you FOIL everything, it's 1 minus a, but it would be 1 minus a plus 1 minus a.
Close. So it's 1, and then you have minus a
Squared.
plus a. Yes.
Oh, yeah, squared. My
minus-
bad. The last one was supposed to be squared. My bad.
Okay, you got it.
I didn't do your way. I kept it in cosine. That's why. My bad.
Okay, got it. So then it's 2 over 1 minus a squared. That's right. So when we keep it in terms of cosine, the Apple method is just to help us with the algebra steps. We don't have to do that. In terms of cosine, this would be 1 minus cosine squared. Don't forget the square. This is called a difference of 2 squares. Okay. In general, when you see a trig function squared, you should think to use the Pythagorean identities. Okay. So let's write out the Pythagorean identity that involves, so we're done with the algebra part. Pythagorean identity that involves sine and cosine. That would be sine squared x plus cosine squared x is equal to 1. When we see a trig function squared, we want to use Pythagorean identities. If we move the terms around, we see that sine squared of x is equal to 1 minus cosine squared of x. This is one that we're going to use often. We're going to use this one often. So that means that we can substitute in for 1 minus cosine squared. That's equivalent to sine squared. Okay. There's one more step we can take. Volunteer, what is the last step?
Square the top and bottom, or yeah, square root.
No, we wouldn't. So square rooting the numerator and denominator wouldn't help us simplify further. Also, we're not given what quadrant sine is in, so we wouldn't know if sine is positive or negative. When the trig function is in the denominator, think about we can move it to the top by getting its reciprocal.
So it'd be cosecant.
Very good. Anytime you can think of this as 2 times 1 over sine squared of x. Anytime you have 1 divided by a trig function, you could rewrite it with its reciprocal function. So recall that 1 over sine is equal to cosecant. Thus, 1 over sine squared is equal to cosecant squared. Okay, so this is going to be 2 cosecant squared x. Let's move this over. Okay, so let's take a look at what we did. We had to start by getting a common denominator. You can use the apple method off to the side to help you with the algebra steps. Then we're able to combine our fraction into 1, and we simplify. When you see a trig function squared, look to use the Pythagorean identities. So sine squared plus cosine squared equals 1, which means we can substitute in 1 minus cosine squared for sine squared. Then when you have 1 divided by a trig function, you can replace that with the reciprocal of that trig function. So 1 over sine is cosecant. Therefore, 1 over sine squared is cosecant squared. Okay, students, any questions with this last example? This last example, we used our even odd identities, Pythagorean identities, and reciprocal identities. And in these chapter 3 problems that ask you to simplify, most likely you'll be using multiple identities to help you simplify the trig expression. When you're getting a common denominator and writing equivalent fractions, you have to multiply top and bottom by the same expression. Okay, so there are a lot of details for us to check for. Okay, so before we wrap for today, is there a volunteer that wouldn't mind sharing their grade book again? Some announcements. We said if
You
the
can do mine
semester.
again.
Okay, thank you, Justin. We said if the semester is pi, last week after week 1, we went through pi over 6. Now that we have finished 2 weeks of the semester, we've gone through pi over 3. So we're 1/3 through with our summer session. Good work, students. Okay. Hang tight. I want to show us in my stat lab. Okay. Okay, so first, if you're still on temporary access, you'll need to take care of that this weekend. The instructions to, let's go. Oh, sorry. The instructions to upgrade from temporary access to full access are in Canvas. So if you go to the Canvas syllabus tab, my stat lab instructions, it shows you how to upgrade from temporary access to full access. Okay, so as we said yesterday, oh, sorry, let me stop the recording.
Recording stopped.
Okay, students. So in your grade book, if you click show overall score, it gives you your current overall percentage. Your current overall percentage includes the first 8 sections of homework, 2 quizzes, and our first exam. So you can see under show calculation, it gives you the percentages in each category. Okay. So we have at least one item in each category except for the final exam. When you go down below, you're able to review past due homework as well as past due quizzes and exams. So let's click on review exam 1. After you submit the exam and students have turned in the exam, you'll be able to review. I want to remind us that when there is a red triangle in the corner, that means this is the correct answer. And then when you click on it, it shows what you answered. And sometimes there's feedback, other times there's not. So what I wanted to comment with everyone, and then if you have individual questions, stay, is the My Math Lab software has its strengths and weaknesses. So a strength is that we can see the results right away. We get feedback immediately, and there's a lot of variations of the problem for us to practice and reinforce. With quizzes and exams, we get to see our score right away. However, there are some limitations. So the software, it's different than if an instructor graded, because it's going to read your answer correct or incorrect, and it does need to be in the form that they ask for. So for example, this one, it says round to the nearest 10th, meaning that your answer needs to be a decimal approximation. Other times it says give the exact answer. Okay,
So then it would be wrong even if you did the exact answer.
Let me finish. So the software will mark it wrong if it's not in the form that it asked for. So if it's not rounded to the correct place, or if it's not in decimal form when they ask for that. I, as an instructor, am well aware of these limitations. So instead of individually going and looking at each question, what I've done in past semesters that has worked is I will be offering extra credit opportunities throughout the semester, knowing that the software has limitations. So note that using My Math Lab, there are going to be some limitations that you have to put in the answer exactly as they ask. However, to account for that, there are extra credit opportunities for this remote live course because I'm aware of the limitations in the software. And there were several students that have gotten perfect scores on the exams. So although there are limitations, really focus on expressing the answer exactly as they asked for. So if they ask you to round, check the rounding instructions. Also, if they ask you to type in a Roman numeral, it needs to be a Roman numeral. Okay. The final exam will be free response, so that would be not graded by the software. And then in exam 2, there's also a free response component. But for the parts of the exam that we're completing in My Math Lab, we'll have to work with the software and understand their limitations. Now, if you think the software has made a mistake, then bring that to my attention and I'd be happy to review that. However, if you're marked wrong because you didn't answer in the form that they asked for, then that's something we just need to pay attention to. And as we move on to calculus and beyond, it's going to be very important that we pay attention to those details, because when we have one thing that's off, that can change the solution. So the software is actually training us to be very detail oriented and pay attention to the instructions. Okay. If you have questions, we can address those questions individually. Otherwise, class is now dismissed, students. We've made it through pi over 3, 1/3 of the semester. Keep up the good work, and I will see you next week. Yes. So those are to be announced. I look at how students do overall quizzes and exams to see if there are opportunities that will help students as we're prepping for exams in the final. So nothing has been announced yet, but I just wanted students to know that there will be opportunities and I'm aware of the limitations with the software. Thank you. Okay. Justin, did you still want to meet individually?